Hello, dear students. I'm back again. It is me, Mr. Idris, a physics teacher. So I'm too excited to see you again. And as I promised you, I'm going to explain and record the entire chapters of a physics book for grade 12 students. So after finishing the section 1 in chapter 1 about the circular motion and the rotational motion of an object, today's lesson, we're going to explain the tangential and centripetal acceleration in section 2. Okay, so the relation between the linear and angular quantities, as you know, there is a relation between the linear and angular quantities. Okay, so in this lesson, I'm going to explain in detail about this relation. For example, in a golf game, when a golfer swings the club in approximate circle around the body, okay, so this, okay, so in this case, the circular motion will occur for this object, okay, and around the body. If the angular acceleration is larger, okay, if the angular acceleration is larger, also the linear acceleration of the club head will be large. So it means that the relation between angular acceleration and the linear acceleration is directly proportional, okay? When the angular acceleration of the object increases, the linear acceleration also increases. So it causes ball to be thrown at a high speed, okay? As you know, in section 1, you have learned about this relation. Delta S is the arc length, which is equal to the angular displacement times the distance from the axis of rotation or the radius of the circular path. So delta S is the linear quantity, delta theta is the angular quantity, and R is the distance from the axis of rotation or the radius of the circular path. And the tangential speed, which is the object that moving in the direction tangent to the circular path, is equal to what? Is equal to angular speed times R. So how can you get this equation? Okay, so we can get this equation, look. Tangential speed, which is equal to angular speed times radius, okay? How can we prove this equation? According to this equation, delta S, which is equal to theta times R. If we divide both sides by T, okay, divided by T and divided by T, S divided by T, as you know that the displacement period of time is equal to what? Is equal to velocity, okay, which is tangent to the direction of the object's motion. So theta divided by time, so we studied, is equal to omega. Okay, the time rate of what? Angular displacement. The time rate of the angular displacement is called the angular speed times r. Okay, so what is the relation between the tangential speed, which is linear quantity, and the angular speed, which is an angular quantity, is directly proportional. What do you mean by directly proportional? It means that when the angular speed increases, what happens to the tangential speed also increases at constant distance from the axis of rotation or the radius of the circular path. Okay? And V is the tangential speed measured in what? Meter per second. Why? Because this is linear. Okay? Linear quantity is equal to the angular quantity times distance from the axis of rotation or radius of the circular path. Omega, angular speed measured in rad per second. R is the radius of the circular path. What does the tangential speed depends on? The tangential speed, according to this equation, it depends on the angular speed and the radius, distance from the axis of rotation. Okay? The tangential speed depends on these two factors. Okay? As you can see, for example, if we have 3 points, okay, because all points A, B, and C, they are moving or they are rotating with the same angular speed, okay, but with different tangential speed. Why? Because object A, B, and C, they are different from its radius, okay, and from axis of rotation. More distance from the axis of rotation produces more tangential speed. Why? Because when angular speed is constant, what is the relation between tangential speed and the distance from the axis of rotation? Is directly proportional. Okay? So we have some notes about the tangential speed in a circular path, one object in a circular path, or on the rotating object. The direction of the tangential speed is always changing because the velocity of the body in a circular motion is always changing due to the change in the direction of the velocity. What do you mean by that? It means that when an object is moving in a circular path, okay, in a uniform circular motion, which means that constant speed, okay, so this object is moving in this circular path, it has a tangential speed, okay, so the direction of the tangential speed is continuously changes. At first, when the object is moving in this direction, at this point, the tangential speed is directed to the upward. When the object reaches at this point, the direction of the tangential speed, which is directed to the west. When the object reaches at this point, the tangential speed is directed to the downward south. Okay, and when the object reaches at this point, the direction of the tangential speed is toward the east. So in this case, when this object is moving in this circular path, this object has tangential speed, which is its direction is continuously changes. The direction of the tangential speed is continuously changes. For example, at this point, the direction of the tangential speed is directed to in this direction. Okay, so this changing of the direction of the tangential speed tells us that this object, when it is moving in a circular path, it experiences an acceleration. So the type of this acceleration that occurred as a result of changing the direction of the tangential speed is called the centripetal acceleration, and we will study after that in detail, inshallah. Okay, so this is the distance or the radius of the circular path, okay, which is directly proportional to the tangential speed at constant angular speed, okay. So note number 2, tangential speed, which is equal to omega times r. Omega is angular speed, r is the radius of the circular path. Omega is the instantaneous angular speed, not average angular speed, okay, rather than the average angular speed, because the time interval is so short here, okay. If two tangential speed vt and two distances are given, so in that case you have to use this relation. Why? Because as you know, vt is equal to what? Omega r, okay. For example, if we have 2 points on a rotating object, okay, point A and point B, okay, so this is the distance from the axis of rotation, okay, so this is point B, sorry, okay. Which point has more tangential speed? Absolutely, the point B has more tangential speed than point A. So it means that VTB bigger than VTA. The tangential speed of the object B is greater than the tangential speed of object A. Why? Because both objects they have a different angular speed? No. The two objects, they have the same angular speed, but different radius. Okay, but different what? Different radius. Because RB bigger than RA and omega B is equal to omega A. Why? Because the angular speed for every point on the rotating object doesn't change. Okay, every point on the rotating object do not change during the rotation. They have the same angular speed. We discussed it in a previous lesson. Okay, so according to the equation of the tangential speed, Vt is equal to what? Is equal to omega r. And omega is equal to what? If you rearrange this equation, omega is equal to Vt over r. So in that case, because the two objects, they have the same omega, omega A is equal to omega B. So that is why instead of omega A, write down Vt of A over Ra is equal to Vtb over Rb. So that is why when two tangential speed or two distances are given in the question, you have to use this relation. Okay? During rotating during rotating an object, all points on the object have same angular speed, same angular displacement, same angular accelerations. Which of the following is correct for an object that rotating on the rotating body? Which of the following is correct for all points on the rotating object? A. All points they have the same angular speed. Yes, it's correct. B. All points they have the same angular displacement. Yes, it's correct. C. All points they have the same angular acceleration if it has. Yes. Okay, so this is very important, and D is all of them. Okay. However, the tangential speed Vt, linear displacement delta S, or tangential acceleration At will be changing because they have different distances from the axis of rotation. The point is that far away from the axis of rotation, they have more tangential speed. Okay. The points that close to the axis of rotation or near the axis of rotation, they have less tangential speed. If the distance from the axis of rotation is different, such as represented in this figure, look at this figure, it is very important. How many points do we have? We have 2 points. Okay, so this figure, it has been brought in the Wizari exam. Be careful. Okay, this is a very good question. How many points do we have? We have 2 points, A and B. Okay, so this is A and this is B. So which one has more distance from the axis of rotation? Absolutely RB bigger than RA. So which point has more angular displacement? Same. Theta A is equal to theta B. Which point has more angular speed? Omega A, same of omega A. They have the same angular speed. As I told you, all points on the rotating object, they have the same angular speed. So, and also they have the same angular acceleration if it has. Okay, but different tangential speed. Why? Because different radius. Which one has more tangential speed, B or A? Absolutely, the tangential speed of B is bigger than the tangential speed of A. So this is very, very important. Be careful. Okay. Look, as you know, the angular displacements are equal, angular speed also equal, angular acceleration equal, but different arc length, different tangential speed, and different tangential acceleration. So the point is farther away from the axis of rotation will have what? Larger tangential speed than the points closer to the axis of rotation. But at each point, the angular displacement remain unchanged or constant. For each point of the rotating object, there is a tangential speed, and it will be changed by changing the radius or angular speed. Okay. Look at question 3. When a wheel rotates about a fixed axis, do all points on the wheel have the same angular speed? Yes. All points on the rotating object have the same angular speed. Okay. Otherwise, the wheel would change its shape. Okay. In the case when the angular speed is not constant or is not same for every point, the shape of the object will be changed, will be various. So when a wheel rotates about a fixed axis, rotating about what? A fixed axis. Do all points on the wheel have the same tangential speed? This is tangential speed. No, be careful. No, they don't have the same tangential speed. They have the same angular speed, not tangential speed. Okay? Now, look at this figure. We have 2 points, B and A. As you know, point A, 1 meter from the axis of rotation, and point B, 1.5 meter from the axis of rotation. Which one has more angular speed? Absolutely, omega B is bigger than V, tangential speed, not omega. VTB is bigger than VTA, okay? But they have the same angular speed. Okay, we have this question, very good question, be careful. A point A and point B are 2 points on a merry-go-round rotating. Okay. We have this question. Look. Okay. So the question says, a point A and point B are 2 points on the merry-go rotating, and point A 1 meter away from the center. Point A 1 meter from the center. This is center of the object, okay? Axis of rotation. Point A is 1 meter. This is point A. Okay? And point B is with a speed of 3 meters per second. The speed is 3 meters per second, which means that RA 1 meter. VTA was given 3 meters per second. Okay? This is VT. And point B 1.5 meter away. The second point is point B. Okay? This is point B. Okay? RB, which is 1.5 meter, and VTB, it should be unknown. Okay? What is the tangential speed of the point B? Which of the following is correct? In that case, you have to calculate VTB. Okay? So how many tangential speeds do we have? We have only one tangential speed, but we have 2 radius. In the case, as I told you, if you see 2 resistance in the, if you see 2 distance from the axis of rotation in the question, to find the tangential speed, you have to use this relation. Okay? So VTA over RA is equal to VTB over RB. Okay, replace VTA 3 meter, RA 1 meter, VTB over 1.5. So VTB, which is equal to 4.5 meter per second. Cross multiply. 1 times VTB, VTB. 3 times 1.5 is equal to 4.5 meter per second. So VB, it should be bigger than VAY because VB has more distance from the axis of rotation. Okay, so this is 4.5 meter per second. The correct answer is what? 4.5 meter per second. And also, if you have a bad time here, you can use this way to solving the tangential speed at B. At first, you have to find omega A, which is equal to 3. Okay, and for point B, you can use the same omega that you found in for point A and replace into this equation to find tangential speed at point B. Sample problem 1E. Look at this sample problem. The radius of the CD in computer is 0.06 meter. What is this? This is R. If the microbe writing on this disk rim has a tangential speed of 1.88 meter per second, what is this? This is tangential speed. How did you know? Because the question mentioned that this tangential speed. In the case, if the question doesn't mention the tangential speed, you can recognize by the units. Okay, by the SI units, you can recognize all physical quantity. Because this number is measured in meter per second, so that is why this is tangential speed. What is the disk's angular speed? Just replace. V is equal to omega R. Omega is equal to VT over R and is equal to 3.14. So look at this table, and this table also is very important. It has been brought in the Wizari exam many times. Be careful. Fill in the unknown quantities in the following tables. Okay, we have three columns. The first column is tangential speed, the second column is angular speed, and the third one is radius or distance from the axis of rotation. For branch A, so it's already solved here. What is unknown? Vt. Omega and r is given, just multiply. The correct answer is here, okay? And for branch B, tangential speed is given. It is positive, okay? Omega is unknown. The radius of the circular path also is given, okay? How can you find omega? Rearrange equation. Omega is equal to V over R. Branch C, Vt unknown. What is this? This is angular speed, which is given, just look at branch B. Tangential speed was given in positive. So the omega also, it should be positive, because when we say Vt is equal to omega times R, the direction of the tangential speed has the same direction of the angular speed. Okay, so when does the direction of the tangential speed will be clockwise? When the object rotating in the direction of the clockwise. So that is why the direction of the tangential speed has the same direction of the angular speed. If tangential speed is positive, the angular speed is also positive. If the direction of the angular speed is clockwise, which means negative, the direction of the tangential speed is also negative. Look at this question. Angular speed is given in negative. What does the negative sign indicate? The negative sign indicates that the object is rotating in the direction of clockwise. Okay? In the direction of what? Clockwise direction. So is equal to 1.2 rev per second. So is it possible to solve a question with the rev per second? No. So that is why you have to convert to what? Rad per second. How can you convert? Multiply by 2 pi. Okay, which is equal to 2.4 pi rad per second. Okay, multiply by 2 pi and time is the radius to get the tangential speed in negative. The last one, the distance from the axis of rotation is unknown. How can you calculate? Just rearrange. R is equal to Vt over omega and is equal to 1.3 meter. So this was question 1. Question 15 from chapter review. A small pebble breaks loose from the treads of the tire with a radius of 32 centimeter. What is the radius? Radius 32 centimeter divided by 132 centimeter. You have to convert to meter divided by 100, which is equal to 0.32 meter. Okay, so that is why you have to convert, because the SI unit of the radius is meter, not centimeters. That is why you have to convert to meter when it's given in the centimeter. Okay, if the pebble's tangential speed is 49 meter, Vt meter per second, Vt is equal to 49 meter per second. What is the tire's angular speed? The tire's angular speed, how can you find it? By using this relation and rearrange. It's too easy, which is equal to Vt over R. Okay, but you have to make sure you can convert 32 centimeter to meter. 32 centimeter is equal to 32 times 10 power negative 2 meter, or you can write down like that, 0.32 meter, the same thing. Okay, a point on rotating rigid object is 0.4 meter away from the center, and it is tangential speed 1.5 meter per second. What is the tangential speed of another point, which is 0.7 meter away from the center? The second point is 0.7 meter away. The first point is 0.4 meter away from the center. Which one has more tangential speed? Absolutely the second one. Why? Because the second one has more distance from the axis of rotation, so that is why it has more tangential speed. As I told you, in the case when two radius or distance from the axis of rotations are given in the question, you have to use this relation. Vt1 over R1, VT2 over R2. Replace. VT1 was given 1.5. R1 also was given 0.4 is equal to VT2 is unknown. It should be bigger than VT1 divided by R1 is 0.7. Okay, cross product. Okay, VT2 times 0.4, 0.4 VT2, 1.5 times 0.7. So VT is equal to what? 1.5 times 0.7 divided by 0.4 by calculator. VT is equal to 2.625 meter per second, which is bigger than the point A. Okay. Okay, guys. So that's all about the tangential speed. It is too easy. Okay, and there is a relation between the linear quantity and the rotational quantity, which is directly proportional to each other. Okay. Now the second topic here, the tangential acceleration and circular motion. Tangential acceleration and circular motion. So before explaining this topic, I would like to give you some information about the circular motion, which is we have two types of the circular motion. Okay, types of circular motion. We have two types of circular motion. The first one, uniform circular motion. And the second one is non-uniform circular motion. Okay, so in uniform circular motion, the object is moving in a circular path with constant tangential speed or with constant angular speed. Okay, for example, if you have this object that's tied at the end of the string or rope and really in the circular path. Okay, so in this case we have a circular path and the object has uniform circular motion. Why? Because the tangential speed of this object and the angular speed is constant. When does the circular motion becomes uniform circular motion? In the case when the object is moving at constant tangential speed. Okay, when does the object is moving at constant tangential speed? When the object is rotating or moving at constant angular speed. Okay, because angular speed and tangential speed has directly proportional to each other. Okay, but in the case when the object is tangential speed changes its direction, the circular path becomes non-uniform circular motion. Okay, so at this point the object has constant tangential speed and has constant angular speed. In the uniform circular motion, the object has only centripetal acceleration. Okay, the object has only centripetal acceleration. Due to the changing of the direction of the tangential speed that centripetal acceleration is producing. And the object has zero tangential acceleration. So when does the tangential acceleration is zero of an object that moving in a circular path? When the circular path is has uniform circular motion, or when the object has constant angular speed, or the object has constant tangential speed, and all of them are correct. Be careful. Okay, I'm going to repeat. This is very important. When does the object's tangential acceleration has zero value? Or when does the tangential acceleration become zero for an object that moving in a circular path? A, when the object has uniform acceleration, yes. B, when the object is moving at constant tangential speed, also it's correct. C, when the object has constant angular speed, also this is correct. So the answer is D, all of them are correct, okay? But for non-uniform circular motion, the object is tangential speed Vt and object is angular speed, which is omega, changes. Okay, do not constant. They do not constant. Changes or varies. So in that case, the types of the circular motion becomes non-uniform circular motion. When does the circular motion becomes non-uniform circular motion? When the object's tangential speed changes or decrease or increase, or when the angular speed changes, decrease or increase. Okay, so in that case, the object has both centripetal acceleration due to the changing of the direction of the tangential speed, and object has also tangential acceleration. Tangential acceleration, AT. Okay, so why? Because the tangential acceleration produces in an object due to the changing the magnitude of the speed of the object. Okay, not the direction, because the velocity is a vector quantity. It has both magnitude and direction. By changing magnitude, the tangential acceleration is produced, but by changing the direction of the tangential speed, the centripetal acceleration is produced in the object. Okay, so this is very important. When does the object has both centripetal acceleration and tangential acceleration? When the object has non-uniform circular motion? Yes. Okay, and also you can say when the object is tangential speed or tangential speed and angular speed changes or varies. In that case, also both types of the acceleration is produced. Okay, let me ask you a question. Orbiting Earth around the Sun, which type of the acceleration exists in the orbiting the Earth around the Sun? Okay, which of the following acceleration is produced? The centripetal acceleration or tangential acceleration? The centripetal acceleration only. Why? Because the circular path of the orbiting Earth around the Sun is uniform circular motion. Why? Because the angular speed of the Earth, which is rotating around, or which is orbiting around the Sun, is constant. So it means that the tangential speed also is constant. So in that case, we can conclude that the object is, or the Earth is orbiting around the Sun, has no tangential acceleration, but has centripetal acceleration. Okay, look at this animation. When, for example, when the Moon is orbiting around the Earth, what is the type of this motion? Is this motion a uniform circular motion or non-uniform circular motion? So you can see it. this is uniform circular motion. What is this? This is uniform circular motion. Okay. So it has uniform circular motion. Okay. So the type of this motion is what? Is uniform circular motion. Okay. And because the tangential speed doesn't change. Okay. This object has constant tangential speed and constant angular speed, which is AT is 0. The object has only centripetal acceleration, which is equal to v squared over r. Okay, because the direction of the tangential speed changes continuously. Okay, so this centripetal acceleration is resulted from the changing the direction of the tangential speed. So why the object has no tangential acceleration? Because the object is moving at constant speed. Okay, Vt is constant and omega also constant. That is why tangential acceleration is 0. Okay. Look, the object has only centripetal acceleration. Okay, this is AC, which is directed toward the center, and we will study in detail after that, inshallah. So, because velocity is a vector quantity, velocity is a vector quantity which has both magnitude and direction. Okay. By changing the magnitude of the velocity of an object, tangential acceleration is produced. Okay, but by changing the direction of the object's velocity, the centripetal acceleration is produced for an object. Okay, so let me ask you a very good question. Be careful. What is wrong with this statement? Object is moving at constant velocity in a circular path. Is this statement true? Absolutely no. This statement is wrong. Why? Because it is impossible for an object moving in a circular path with constant velocity. Okay, so what is wrong with this statement? The wrong is when you say constant velocity. The object's velocity can never be constant in a circular path. Why? Because velocity is a vector quantity. It has both magnitude and direction. In a circular path, then, for example, when the object's speed doesn't change, the object has no tangential acceleration. But because the tangential speed changes continuously, so that is why the object has centripetal acceleration. Okay? So, if you corrected this statement, you have to say the object is moving in a circular path with constant speed, not constant velocity, because velocity doesn't constant in a circular path. So when does the velocity becomes constant? In a linear path. For example, you can say the object is moving in a linear path to the direction of the east with constant velocity. This is correct. Why? Because neither the direction and nor the magnitude doesn't change in that case. Okay? But for circular path, it is impossible to say constant velocity. Why? Because the direction of the object changes continuously. Okay? Let's go back to the tangential acceleration. The definition of tangential acceleration is also very important, and it has been brought in the Wizari exam. AT, which is the symbol of tangential acceleration, the instantaneous linear acceleration. What is this? Instantaneous linear acceleration of an object directed along the tangent to the object's circular path. Okay, directed along what? Tangent to the object's circular path if it has, and measure it in what? Meter per second. Or you can define in another way the time rate. The time rate of what? Changing the instantaneous speed. What about in the case the speed doesn't change, at constant speed 80 is 0. Okay, and in the tangential direction of the circular motion. As you can see in this figure, to calculate tangential acceleration, you have to use this equation. The time rate of changing the instantaneous tangential speed. Okay, so this object, when the object is moving in a circular path, okay, it is, for example, if it is speed, it's not constant, it has a tangential acceleration and centripetal acceleration. Where is the direction of the tangential acceleration? Is the tangent to the direction of the circular path. Okay, so we have two cases: speeding up or slowing down. Okay, speeding up and slowing down. In the case of speeding up, the angle between Vt and At is 0 degree. So when does theta has 0 degree? In the case of speeding up of an object. Okay, for example, this is circular path of an object. Okay, this is Vt. In the case of speeding up, this is At. What is the angle between these two vectors? 0 degree. Theta is what? 0. When does angle between tangential speed and tangential acceleration becomes 0 degree? In the case of what? Speeding up. Be careful. Okay, but in the case of slowing down the object, for example, okay, the direction of the tangential speed is here, but the direction of the tangential acceleration is opposite direction. Okay, so in that case, in the case of slowing down, the direction of, or the angle which is theta between Vt and At is 180 degree. Okay, so in that case, what is the angle between Vt and At in the case of slowing down? Is 180. Okay, so this is very good point. Be careful. The relation between the tangential acceleration and rotational angular acceleration, okay, it is like that. Tangential acceleration is equal to what? Is equal to angular acceleration times the radius, okay, or the distance from the axis of rotation. So what does the tangential acceleration At depends on the tangential acceleration according to this equation. It depends on the angular acceleration and distance from the axis of rotation. So how can you prove this equation? So we can prove this equation like that. Okay, so to prove this equation, At is equal to alpha times r, angular displacement time is the distance from the axis of rotation. So we have to start from this equation, which is equal to Vt is equal to what? Omega r, the equation of tangential speed. Both sides is divided by t. T. Vt divided by delta t is equal to what? Is equal to 80. Okay? And omega divided by time is equal to what? Alpha. Angular acceleration, which is the time rate of changing of the angular speed. Okay? Multiply by what? By r. What is relation between tangential acceleration and angular acceleration? Is directly proportional. More angular acceleration provides more tangential acceleration at constant distance from the axis of rotation. What does tangential acceleration depend on? It depends on what? Angular acceleration and the distance from the axis of rotation. So we have some notes about the tangential acceleration. Okay. The angular acceleration in this equation refers to the instantaneous angular acceleration as we discussed it and we describe it in the previous lesson about the instantaneous angular speed. This is the same thing for the angular speed is correct. Okay, which is equal to what? Alpha r. What is alpha in this equation? Is the instantaneous angular acceleration, not average angular acceleration. Okay. Velocity is a vector quantity. What do you mean by vector quantity? What do you mean by vector quantity when we say something in physics is a vector quantity such as force, velocity, momentum? Okay. When we say something is a vector quantity, it means that this object has both magnitude and direction. By changing each of these two factors, the acceleration is produced. By changing the magnitude of the velocity, tangential acceleration is produced. But by changing the direction of the tangential speed, the centripetal acceleration is produced. Okay? Tangential acceleration, both magnitude and direction. And tangential acceleration, AT, produced by changing what? The magnitude of the velocity. In the case of speeding up, AT is positive. Alpha is also positive. And angular speed increases. Theta is equal to what? 0. When does angle between VT and AT is equal to 0? In the case of what? Speeding up. As I mentioned a few minutes ago. Note number 4. In the case of slowing down or slow down, which one is bigger? V initial is bigger than V final. In the case of slow down, alpha becomes negative and tangential acceleration is also negative. Why? Because tangential acceleration is the time rate of changing of the velocity. And the angular speed decreases in the case of slow down, and the theta is equal to 180 degrees between what? Vt and At. If a linear speed of an object is constant, which means that the angular speed is also constant, alpha and At, both of them become 0 or remain constant. And the angular acceleration is 0, okay? Not constant, 0, okay? So you can see constant. So tangential speed and tangential acceleration of points are different. Okay? The tangential speed and tangential acceleration of points are different. Why? Because the equation of tangential acceleration and angular acceleration varies with the varying of the distance from the axis of rotation. They are not equal. Both of them are parallel to each other and angle between them is 0. What is the angle between Vt and At is 0 in the case of speeding up and 180 in the case of slowing down. Okay? So the entire point on rotating rigid body rotates with the same angular displacement we mentioned before, has the same angular displacement and angular acceleration. But tangential speed and tangential acceleration are different from each other or for each other because of them depend on distance from the axis of rotation. The point is at the edge of the circular path has the largest tangential speed. Why? Because the edge is located farthest from the axis of rotation. As you can see in this figure, which one is bigger, VA or VB? Absolutely VB. Why? Why VB bigger than VA? Sorry, VA. Why VA bigger than VB? Because RA bigger than RB. So because they have the same angular acceleration, so that is why Vt is, they have the same angular speed, Vt is equal to omega r. Okay, let's solve the sample problem and the practice. Sample problem 1A, a spinning ride at a carnival has an angular acceleration. What is this? This is angular acceleration, alpha, which is equal to 0.5 rad per second squared. How far from the center? What do you mean by how far? R. Who has tangential acceleration 3.3 meter per second squared? Be careful between these two numbers. The first one is alpha, the second one is AT. Write down the equation, AT, which is equal to alpha R. Rearrange equation, AT over alpha. Replace, and it is too easy, okay? So the question 1 in practice 1F, a child on a merry-go-round undergoes 1.5 meter per second squared. What is this? What is this value? This is AT or alpha? This is AT. How did you know this is AT? By the units. Meter per second is the unit for tangential acceleration, but rad per second represented for the angular acceleration. If the merry-go-round's angular acceleration, what is this? Angular acceleration. How far? Just replace. Just plug into the equation and you can find out the value of the R. Question 2. What is the tire angular acceleration if the tangential acceleration at a radius of 0.15 meter is 9.4 times 10 power negative 2 meter per second? What is this? This is AT. What is this? This is R. Alpha is equal to what? Is equal to AT over R. It is too easy and they have been brought in the Wizari exam. Be careful. Okay? So that's enough for today. Inshallah, in the next lesson, we will continue to solving all questions which is related with the tangential acceleration and the tangential speed. Thank you for listening and hope you benefited from my lesson.